Arithmetic logic unit accepts operands from registers and performs arithmetic or logical transformations. The result may be returned to a register or memory. Status of arithmetic logic unit operation is available for writing into a special register. A microprocessor basically consists of a program memory, a control unit, registers for temporary data storage, and an arithmetic logic unit. The group of file registers is called the data memory. Data is transferred to the data memory through an 8-bit data bus. The address bus of the data memory is 12 bits wide. It follows that there are 496 registers in the data memory. This figure illustrates how the microcontroller adds the contents of the file register 070 and 083. In the first step, the number stored in register 070 is transferred to the working register. In the second step, the content of working register and the content of the register 083 are added. The result is then stored back to the register 083. Working register is a particular memory location in the data memory. Many operations require that one of the operands should be placed in the working register before the operation can be performed. All the operations in the microcontroller are controlled by the instruction decode and control unit. It is the responsibility of this unit to synchronize and coordinate all internal and external data transfers and transformations. The control unit performs this control using several control lines which are not shown explicitly in the figure. By filling the program memory with appropriate instructions, you can determine which operation will be performed by the microcontroller. This is a program for adding to numbers stored in the data memory. It consists of 2 instructions stored in consecutive memory locations. Each instruction tells the control unit to transfer or manipulate some data. Now let's watch the execution of the addition operation once more. The instructions will be highlighted while they are executed. By arranging the right instructions in the right order, you can make the microcontroller carry out a desired task. Let us investigate the instructions of the program in more detail now. When the microcontroller starts working, the control unit reads the instructions from the program memory one at a time. This is called instruction fetching. In this way, the microcontroller understands what it is supposed to do. Consider the first instruction in the figure. The first 6 bits of the instruction word is called the opcode. Opcode is an abbreviation for operation code. For this particular instruction, the opcode is 010100. This operation code dictates the control unit to move the contents of a file register. The bit following the opcode is called the destination select bit. A 0 in the destination bit position tells the control unit that the destination of the move operation is the working register. Having understood that it is supposed to perform a move operation from a source register to the working register, the control unit then checks the remaining bits of the instruction to find out the address of the source register. The least significant byte of this instruction is called the operand of the instruction. It specifies the address of the source register. For this particular program, the operand is 01111110, or 70, in hexadecimal. The opcode and operand together tell the control unit to move the content of file register 70 to the working register. We have not discussed the function of 1 bit so far. This remaining bit is called the RAM access bit. You are going to learn its function in a later section. After executing the move instruction, the next instruction is fetched. This opcode denotes an addition operation between the working register and the file register specified by the operand. Since the destination bit is 1 this time, the result of this operation is sent to the register A3 and stored there.